All right, 4.2 L'Hopital. You guys are going to like this one. It takes a lot of the stuff that we've done in the past with limits, and yes, we're revisiting limits. They're coming back a little bit. But it gives you an alternate way to solve limits. So here's how the rule works, all right? So let's say I'm taking the limit of a fraction. The first thing that we normally try to do is whatever we're taking the limit to, like when I'm going to C, the first thing that we usually try to do is plug that right into the function and see if we can come out with a number. Now, the way L'Hopital works is when I do that direct substitution, when I plug in that number to the top and when I plug in that number to the bottom, if I end up getting something like 0, oh, where'd my pen go? If I end up getting something like 0 over 0 or infinity over infinity or negative infinity over negative infinity. So if the top and the bottom both go to 0 or infinity, then I can use L'Hopital's rule to simplify the equation. What I can do is I can take the derivative of the top and the derivative of the bottom, and I can use those for my limit. So let me kind of show you. It's hard to explain without an example that you're walking through. So example number 1, limit as x goes to infinity of x over e to the x. So if I just look at the top, the limit as x goes to infinity of x equals infinity, because I just plug it in. Now, the limit as x goes to infinity of the bottom of e to the x equals e to the infinity, which is just infinity, right? So the top and the bottom go to infinity. And because they both go to infinity, I can adjust the equation. I can change the equation. I can take the derivative of the top and the bottom and use the limit of those instead. I have to be a little bit careful about the way that I write it. So the first thing I need to show that the top goes to infinity and the bottom goes to infinity separately. So then I can say that the limit, here we go. So then I can say by L'Hopital, because the top and the bottom limits are the same, the limit as x goes to infinity of the original equation is equal to the limit as x goes to infinity. Now I can take the derivative of the top and the bottom. The derivative of the top is 1. The derivative of the bottom is e to the x. So if the top and the bottom go to the same value, 0 or infinity, I use derivatives to simplify, and now I take the limit of the derivative. So the limit of as x goes to infinity, when I plug it into the top, well, I can't. When I plug it into the bottom, I get e to the infinity, which is just 0, because my bottom gets huge, right? So my overall limit just becomes 0. All right, let's look at number 2. The limit as x goes to infinity, same numbers, right? If I plug infinity into the top, it's going to go to infinity. If I plug infinity into the bottom, it's going to go to infinity. Here's what a lot of people do and lose points. They say, oh, the limit as x goes to infinity of this is infinity over infinity. So by L'Hopital, you can't do that. The limit is not infinity over infinity because infinity over infinity is not a number. That's not a valid answer. The way that I have to say this is that the limit as x goes to infinity of the top is equal to e to the infinity, which is equal to infinity. The limit as x, wrong place, as x goes to infinity of the bottom is equal to infinity. Those are equal to each other. So by L'Hopital, the limit as x goes to infinity of the original of, whoa, it's early, guys, of e to the x over x is equal to the limit as x goes to infinity of the derivative of the top, which is e to the x. The derivative of the bottom is just 1. Does this make sense, right? So now when I directly plug it in, my limit is now just e to the infinity over 1, which, depending on who you're talking to, because it's going to infinity, you can say it does not exist, or you can say that it's going to infinity, all right? Number 3, the limit as x goes to 0 of x over e to the x. So if I look at direct substitution, if I plug 0 into the top, I get 0. If I plug 0 into the bottom, I get e to the 0, which doesn't equal 0, it equals 1. So this limit equals 0 on top, 1 on the bottom, which is equal to 0, right? I'm allowed to do that. So I don't use L'Hopital on that one because the bottom doesn't go to 0, and because I have an answer. Why would I take a derivative and more limits when I already have the answer to the equation? So let's look at some more interesting examples. Okay, those are very, very plain, simple. Let's look at some actual meaty questions here. So the limit is x goes to 0 of 3 minus 3e to the 3x, wow, over x. So what I normally do is I plug 0 into the top and I draw myself this little arrow, because when I plug 0 into the top, I end up with 3 minus 3, and that goes to 0. When I plug 0 into the bottom, that goes to 0. That's not enough for the AP test, but that's enough for me to know that I can use L'Hopital without doing a whole bunch of algebra and writing. I know the top goes to 0, bottom goes to 0. So I'm going to take the time now to say the limit as x goes to 0 of the top equals 0, which also equals the limit as x goes to 0 of the bottom. I've already checked that that's true, so I just have to write that that is true, okay? And nowhere on my paper does it say that the limit equals 0 over 0, because as soon as they see that, you get in trouble. So the limit of the top equals 0, which equals the limit of the bottom. So now, because that's true, I can say by L'Hopital's rule, the limit as x goes to 0 of the original, 3 minus 3e to the 3x over x, is equal to the limit as x goes to 0 of the derivative of the top over the derivative of the bottom. Please don't use the quotient rule. I'm not using the quotient rule. I'm taking the derivatives of the top and the bottom separately because L'Hopital lets me, all right? So the derivative of the top, the 3 goes to 0. Negative 3e to the 3x becomes negative 9e to the 3x, right? Because I have to drop the 3 when I do my u prime. Yep, that looks good to me. The derivative of the bottom is just 1. Okay, now I can just plug 0 right in because I don't have anything else going on the bottom. So I can just take this 0, plug it in right there. Negative 9e to the 3 times 0 just equals negative 9 times e to the 0, which equals negative 9 times 1, which equals negative 9. You don't have to show all the algebra, but on the video, I would like you to see why I got what I got, okay? All right, number 5. First thing I want to do, never mind. Number 5 says it doesn't want me to do L'Hopital's rule. It doesn't want us to use it. So if I do this the old way, what am I going to do? I'm going to simplify. I'm going to factor the top. So we get the limit as x goes to -1 of 2 times x squared minus 1 over x plus 1. So the limit as x goes to -1 of 2 times x plus 1 times x minus 1 all over x plus 1. The x plus 1's cancel, so the limit as x goes to -1 of 2 times x minus 1 over nothing. There's nothing on the bottom, right? Just 2 times x minus 1. When I plug in -1, I get 2 times -1 minus 1, so 2 times -2. So I get -4, all right? So that's how we would have done it. But now that I know L'Hopital's rule, the limit of the top, if I plug in a -1, I get 2 minus 2, which is 0. If I plug -1 into the bottom, I get -1 plus 1, which is 0. So I can say that the limit as x goes to -1 of 2x squared minus 2 equals 0, which is also equal to the limit as x goes to -1 of x plus 1. Since those limits are both 0 by L'Hopital's rule, I can say that the limit as x goes to -1 of 2x squared minus 2 over x plus 1 is equal to the limit as x goes to -1 of the derivative of the top over the derivative of the bottom. So on top, I get 4x. On the bottom, I get 1. And see how much easier it is to plug it in now? I can plug in my -1, and that just equals 4 times -1, which equals -4. Okay, so they both get me to the same place, right? They both get me to -4, but I have more than one option. If they go to 0 or if they both go to infinity, all right? Couple of reminders before we get down to these problems. Really, really, really careful that at the beginning of these problems, you never say that the limit equals 0 over 0 or infinity over infinity. Okay, that is one thing they're very picky about, because that is not what the problem is. Yes, when you plug this in, you end up with 0 over 0, but that is not what the limit is equal to. Yes, they both go to 0, but that's not what the limit equals. So please don't write that at the top. A little note here. Just because a problem looks like a candidate for the rule doesn't mean it is. So you have to check and make sure that it actually gives you one of those forms, 0 over 0 or infinity over infinity. The nice thing about L'Hopital is you can use it more than once. As long as you keep getting those indiscriminate forms, you can keep using it again and again. So number 7, if I want to check for L'Hopital, so if I plug in -infinity on top, I square -infinity, and that gives me positive infinity. If I plug in -infinity on the bottom, the negative x turns it into a positive infinity, so e to the infinity is equal to infinity. So my top goes to infinity, my bottom goes to infinity, so I know I can use L'Hopital's rule. So I'm going to say that the limit as x goes to -infinity of x squared is equal to infinity, which is equal to the limit as x goes to -infinity of the bottom, e to the -x. Those, I have to state that to use L'Hopital's rule, okay? So by L'Hopital. Now, obviously, if I'm doing the multiple choice, I don't have to state that because it's a multiple choice test. All they want is the right answer. But if this was a free response section, you would have to state that those are equal to each other. Multiple choice, you can take all the shortcuts you want. Free response, you've got to make sure you show the right steps. So by L'Hopital's rule, excuse me, the limit as x goes to -infinity of the original equation is equal to the limit as x goes to -infinity of the derivative on top over the derivative on the bottom. Okay, now let's try plugging in -infinity again. When I plug it into the top, I get 2 multiplied by -infinity. That gives me -infinity. On the bottom, I get e to the positive infinity, but the negative sign in front. makes the bottom also go to negative infinity. So the limit as x goes to negative infinity of the top is equal to negative infinity, which equals the limit as x goes to negative infinity of the bottom. So again, by L'Hopital's rule, and I know there's a lot of justification here. There's a lot of writing in these problems. It makes up for it with the lack of algebra that you have to do within the problems, all right? And most of the time, these questions are multiple choice questions. So you don't, on the actual test, you're not having to use all of this justification most of the time. But if it was a free response, we just want to make sure you know how to do it. So the limit as x goes to negative infinity of 2x over negative e to the negative x is equal to the limit as x goes to negative infinity. Now the derivative of the top is 2. The derivative of the bottom goes back to positive e to a negative x. So now when I plug in negative infinity, I'm not going to get the same thing on the top and the bottom because the top is just 2. So this is equal to 2 over infinity, which is equal to 0. Because my bottom's going to get really big and my top's going to stay 2. So all of that work to find out that my limit is 0. Okay, number 8. Natural log, limit as x goes to 1 of the natural log of x minus x plus 1 over x squared minus 2x plus 1. So let's check and make sure L'Hopital works. If I plug a 1 in on top, I get 1 minus 1, which, natural log of 1, which is 0, minus 1, which is negative 1, plus 1, which is 0. On the bottom, I get x squared, so 1 squared is 1, minus 2 is negative 1, plus 1 is 0. So the limit as x goes to 1 of the top is equal to 0, which is also equal to the limit as x goes to 1 of the bottom. Okay. Now, as far as why L'Hopital works, we'll talk about that a little bit more when I come back. That's not something I want to try to do over a video. We'll try to find some time in one of our next class periods that we can talk about the why behind this. It's not really important to using it, but as far as our curiosity goes, that is something that I know some of you like to see. So those limits are equal. So by L'Hopital, I can say that the limit as x goes to 1 of that ugliness, that really is an ugly fraction, is equal to the limit as x goes to 1. Now I take the derivative of the top, which is just 1. Let's see, natural log of x is 1 over x. Negative x just becomes negative 1. The derivative on the bottom is 2x minus 2. Okay, so now if I plug in a 1, if I plug a 1 into the top, I get 1 over 1, which is 1 minus 1 is 0. If I plug a derivative, the 1 into the bottom, I get 2 times 1, which is 2 minus 2, which is 0. So again, they're the same. So I can say that the limit as x goes to 1 of the top is equal to 0, which is equal to the limit as x goes to 1 of the bottom. Okay, so by L'Hopital, and technically, one of the graders once told me that doesn't even have to be there. If you've shown this step, then you don't have to say by L'Hopital. You just have to show the justification, but you don't have to name the rule, which is kind of weird to me. So I still do it because then it helps me keep track of what's going on, right? So the limit as x goes to 1 of 1 over x minus 1 over 2x minus 2 is equal to the limit as x goes to 1. Now I've got to take the derivative of the top. So the derivative of the top, if I make this an x to the negative 1, becomes negative 1 over x squared. The minus 1 goes away, and on the bottom, I get 2. So now I can easily just plug in the 1. I plug in the 1 on top, and I get negative 1 over 1, right? Yeah, negative 1 over 1, so I get negative 1 on top, and I get a 2 on the bottom. So my limit of that great big giant ugly mess is just -1/2. And this is absolutely the kind of question that you would use L'Hopital rules on. A lot of these other ones, quick, easy problems, right? This one would be a disaster to try to do any other way, but L'Hopital makes that big, ugly, scary looking mess just simply turn into -1/2. So homework problems, go ahead and try all of them. I don't think there's any that I wanted you to leave out. The first 9, you're not going to use L'Hopital on all of them, especially look at like number 5 and number 6. You're going to use a right hand limit. You're going to use a left hand limit. So there's a little bit of limit review there. But there is going to be a lot of L'Hopital going on today. So good luck. If you have questions, reach out. I probably won't get to them quickly, but I'll get to them as soon as I can.